Good morning. Today we will see the next part of module 5, lecture number 2. We had started the 5th module, that is communication system, in the subject advanced electronics engineering. This is the course for first year, and previous day we had covered the introductory part to electronic communication. Then we had seen what is the need of modulation, what are different types of channels. Then we had seen that if frequency of the modulated waveform is increased, it can travel for longer distance. If modulation is done, then antenna height required to be put for transmitting of the signal is less. Finally, in previous lecture we had seen basic introduction to amplitude modulation. What is the equation for amplitude modulation? What is the waveform for amplitude modulation? And what is the necessity of amplitude modulation? That also we had seen last day. Today we are going to take it from there. What first we are going to see today is what is meant by frequency modulation. So this is a type of analog modulation scheme where the frequency of the carrier signal is changed as per the amplitude of the modulating signal. So if I draw a baseband signal or modulating signal like this, which is sinusoidal with time t in seconds, so this I will show as modulating signal, and then obviously a high frequency carrier. So this frequency I am naming as FM. Carrier is always a very high frequency component. So for amplitude modulation also we had seen the same. Frequency modulation also will be seeing same. It's a very high frequency signal like this. And this frequency I am calling as FC. Here there is the amplitude of modulating signal given by AM. This is minus AM. This is AC. This is minus AC. So in case of amplitude modulation, what we had seen was the amplitude of the carrier was getting changed as per the amplitude of the modulating signal. That means here modulating signal was more. In this case, this portion of the carrier amplitude was increasing. Whereas in this case, amplitude of the modulating signal was less. So in this case, the amplitude of the carrier signal was getting squeezed. So in case of amplitude modulation, what we had seen was the carrier amplitude was increasing and decreasing as per the modulating signal amplitude. But in case of frequency modulation, as the topic suggests, in short, frequencies modulation is called as FM. What we will find is this Hc will be a function of AM sine 2 pi SMT. That means carrier frequency will be changed as per the instantaneous amplitude of the modulating signal. That means wherever we will be finding amplitude of the modulating signal is more, there this carrier frequency will be Fc plus delta F. That means frequency of the carrier will increase as per the increment in the amplitude of the modulating signal. In the same way, whenever we are finding that amplitude of the modulating signal is less, in that case at this point we will be finding this frequency will be reduced as per Fc minus delta F. That means in case of frequency modulated waveform, so this is modulating signal, this is carrier signal, which is a high frequency signal. Below I will draw, this is modulated signal. So in case of frequency modulation, what we will see is this modulated waveform will be a function of frequency and variable function of frequency, and that change in frequency will be caused by amplitude of the modulating signal. That means this Fc, AC and AC amplitude will remain same. This is AC and minus AC. There will be no change in that. So amplitude, there will be no change. As we found in case of amplitude modulation, amplitude of carrier was changing. But in this case, what we will find is exactly at this point, the frequency of the carrier will become very high. Frequency high means time period will become less, like this. So this is a very high frequency signal like this. Okay. So in this case you are finding this is FC frequency, but this frequency will be FC plus delta F. Whereas exactly at this point where amplitude of the modulating signal is less, we'll be finding the frequency will be less. Frequency is less means time period will be more, like this. Okay. And exactly at this point where modulating signal amplitude is 0, exactly at this point we'll be finding the same frequency FC will be kept. That means here the frequency of modulated signal will be FC. So this frequency will be FC, this frequency will be FC minus delta F, and this frequency will be FC plus delta F, and accordingly. So just before this amplitude was less, so frequency will be less as well, like this. Between this part and this part again frequency will be reducing like this. Okay, and here the frequency will be further less, and after that as amplitude is increasing again you will be finding that the frequency also is increasing like this. So this is the frequency modulated waveform where the amplitude of the frequency modulated waveform is same as the carrier amplitude. This is plus AC, this is minus AC. Here also this is plus AC and this is minus AC. But what change happens is whenever the amplitude is 0, the same FC will be kept. So exactly at this point frequency is FC. Whenever it is higher amplitude, at that time frequency will become very high. It will be FC plus delta F, where delta F is called as the deviation in frequency. Delta F is called as deviation in frequency in both directions. So for positive peak amplitude in modulating signal, this frequency will be positive deviation. So this is highest frequency component we will find in modulated waveform. So this will become FC plus delta F. Whereas whenever this is coming least amplitude of the modulating signal, in that case this frequency will become least. It will become FC minus delta F. So what we can find is this is modulated. This is modulated and this is called frequency modulated waveform. In this case we will be finding all frequencies in between two extremes. Now what are the extremes? Here comes positive extreme in modulated waveform, here comes negative extreme in modulated waveform. That means this is maximum frequency in modulated. At this point we will find minimum frequency modulated. So it will be changing in between FC plus delta F and FC minus delta F. Just if we want to take a small example, in that case we can say that suppose we want to transmit modulating frequency of 1 kilohertz. Obviously this is an audio frequency range. Some audio frequency is created which is having a frequency of 1 kilohertz. This we want to transmit for a longer distance. Same fundamental, 1 kilohertz we want to transmit for a longer distance. It requires very high antenna height which is unrealistic. It requires some carrier to be taking it from one place to another, because 1 kilohertz being a lesser amount of frequency cannot travel for longer distance. That's why you are using a carrier frequency. In that case, suppose FC we are taking as 1 megahertz. So it's a very high frequency can travel longer. So in that case, we are using the carrier frequency as FC is equal to 1 megahertz. So whenever I am designing this kind of a modulator, that is frequency modulator, in the FM modulator, in that case 1 kilohertz is to be transmitted for a longer distance by using a carrier of 1 megahertz. In that case, we'll be finding that in the modulated waveform, if this amplitude is plus minus AC, this amplitude also will be plus minus AC, so there will be no change in amplitude of the carrier in case of frequency modulated waveform, but the changes will come in the frequency of the frequency modulated waveform. In that case, all the frequency components we'll be finding here will be in the range of 1 megahertz plus minus 1 kilohertz. That means from 999 kilohertz here, this frequency will be 999 kilohertz, this frequency will be 1001 kilohertz, and whenever this is amplitude 0, here we find 1 megahertz or 1000 kilohertz, like this. And this thing will keep on propagating. And obviously we can find that this property of amplitude is kept inside the property of frequency. So whenever I am saying that frequency is more in modulated waveform, means exactly at this point whatever modulating amplitude is there, that is higher amplitude. In this case we are finding frequency is less than FC. That means whatever amplitude of the modulating signal is there, that will be having lesser amplitude in case of modulating signal. So this is the modulated frequency modulated waveform, and this is how it propagates. And we have to remember that the frequency of FM waveform is ranging from Fc plus minus delta f, where delta f is called as deviation. That frequency deviation is caused by the amplitude of the modulating signal. So very important definition for frequency modulation. It is a modulation where frequency of the carrier signal is changed as per the amplitude of the modulating signal. So that is FM. Now let us hear some of the features of frequency modulated waveform. It is said that Fc is increasing as per amplitude of the modulating signal. So this is Fc here, this is Fc is increasing, amplitude is increasing for modulating, so Fc is increasing to Fc plus delta f. When input modulating voltage is 0, at that time modulated carrier is equal to Fc. Exactly, you can find here the input modulating signal is equal to 0, so modulated waveform frequency will be same as carrier frequency, that is Fc. Deviation frequency is given by Fd. Fd is here I have shown as delta f, like this. So total range of frequency is Fc plus minus delta f or Fc plus minus Fd, like this. So we can call it Fd, we can call it delta f, same thing. Modulation index, that is the important thing. So frequency modulation, modulation index, frequency modulation, modulation index. This is given by, the formula is Fd divided by Fm. Okay, so that is the Fd is nothing but the deviation and Fm is nothing but the modulating frequency. Okay, so deviation divided by modulating frequency, that is the modulation index. Modulation index for frequency is modulation is given by m suffix s, like this. Okay, so this is all about basic knowledge for frequency modulation. Now we will see the basic difference between propagation of amplitude modulated waveform and propagation of frequency modulated waveform. One thing we have to always keep in mind that amplitude modulated waveform travels longer distance, and frequency modulated waveform, it cannot travel longer distance. So whenever I am saying AM waveform,